Let's do this two proportion hypothesis test example. This is number 21 or number 29 from chapter 21 in your book. Go ahead and pause and read this. Okay, the first thing we're going to do, always, every single time, you must write this. Let P represent the proportion of success in your population. Here our population is voters. Success is people that support him. So this statement is necessary. Then we write down our samples. We don't know ahead of time who's group 1 and group 2. I've already done the problem, so I know who's 1 and 2. But in before this scandal, 54% of people out of 630 supported him. So my P hat, my sample success rate, was 54%. Then x1, to get the x's, we multiply. 54% times 630 is 340.2. But remember, you can't have half a person. We always have to round x. It must be a whole number. Similarly, over here for group 2, the afters. Because before had a higher success rate, they get to be group 1. Group 1 is the one with the higher P hat. Then our hypotheses. Null hypothesis is always the same. P1 minus P2 equals 0. It's okay if you want to write it like this. This means the same thing. P1 equals P2. That says, mathematically, that his support rate before is the same as his support rate after. That's what we're trying to disprove. Then the alternative hypothesis could be written either way. We could say the difference is positive or P1's bigger than P2. Because we want to know, did his support decrease? Is after less than before? That's the same as saying before is bigger than after. And then I made this up. I got to choose. On a test, I'll always tell you what to use, but I chose alpha 5%. We plugged everything in our calculator. We went stat over to tests and down to number 6 and typed in our x1, our n1, x2, and n2. This is the alternative we wrote, greater than. And then we hit calculate. And all we care about here, we should check and make sure our P1 hat and P2 hat are accurate. They are. What we care about right here is the p-value. That's the probability of getting this sample if the null hypothesis is true. All right, so that's 12%. Now we compare that with alpha. Alpha was 5, our p-value is 12. 12 is bigger than 5. Anytime we're greater than alpha, we fail to reject the null. We draw no conclusions. We do not have strong evidence of the ha. We do not have strong evidence that his support before was greater than his support after. So that does not indicate a decrease in his support. Okay, then question B says, is this a type 1 or type 2 error? Here's our chart for errors. If we failed to reject when the null hypothesis was actually false, then that would have been a type 2 error. And then part C says, if we concluded there was a difference, we didn't conclude there was a difference. I don't know why they included this question, because we could just say we didn't. We did not draw any conclusions. But let's go ahead and do the confidence interval anyways. So on the calculator, that's stat, test, B. This is a 2-prop interval. because we had 2 samples. All the numbers are already in here for us. We hit calculate. I decided to do a 95%. And we get this interval. Remember, these are weird. Anytime you get 2 negatives, you pick the wrong group 1. If you get a negative and a positive, that's the same thing as failing to reject the null hypothesis. You can't decide who's better. If you get 2 positives, then group 1 was better. So we got a negative and a positive. We can't draw a conclusion about who was better. Remember, your hypothesis or your confidence interval is always how much higher group 1 is than group 2. So what's it mean to be negative higher? That means lower. So because this interval has a negative and a positive, we can't rule out the possibility that the difference was 0. Remember, we're measuring the difference between the groups. So his support could have remained the same. That's why we failed to reject the null. And then the interpretation of this interval is we're 95% confident that the proportion that supported him before is between 2% lower because of that negative and 8% higher than the proportion after the scan.